It's go time.
Welcome to Go Time, your source for diverse discussions from all around the Go community.
Good news, everyone!
Our new weekly podcast plus email newsletter covers all the developer news that's worth your attention. We keep it brief, entertaining, and always on point. I'd love for you to check it out at changelog.com/news.
Seriously, do it.
Thanks to our partners at Fastly for shipping Go Time all around the world to wherever you listen. And to fly.io. Host your app, close to your users, no ops required. Okay, here we go.
Hello, everyone, and welcome to Go Time. Today, I'm joined by three guests and Chris. Our first guest is Jonathan Norris, who is the co-founder and CTO of DevCycle. He's built multiple developer-facing products, and he has experience in designing and building large, scalable systems. Jonathan, how are you doing?
Hey, I'm doing great and glad to be here and really excited to talk about everything we're working on and a little bit of WebAssembly and Go.
Happy to have you. Our next guest is Adam Wooten. He's the chief architect at DevCycle, and he's responsible for our infrastructure, performance, and system scalability. Adam, how are you doing?
I'm good. Excited for the chat today.
Happy to have you. And third, we have Brad Van Vught, who has joined us in the past to talk about Battlesnake, which is a company he founded. Battlesnake has been acquired by DevCycle. I believe that was earlier this year, and he's now the head of strategy and growth at DevCycle. Brad, how are you?
Good. How you doing, John?
Good. It's feels like it's been a while since you've been on.
Yeah, it's been a little bit.
I don't think it actually has been that long, but
yeah,
but it just feels like it.
Always happy to show up.
And then Chris is also joining us. Chris, how are you?
I'm doing well. Glad to be back on some episodes. I was gone for a bit there, so.
Yeah, I don't think I've hosted with you in a while.
Yeah, it's been probably like a year or so.
It somehow it feels like I was just randomly on episodes with the same two people all the time, and I don't know how that happened, but okay. So today we're talking about WebAssembly, and basically the general idea is I want to sort of start by talking about what WebAssembly is, why people should care about it, and then we can talk a little bit more about your experience, Jonathan, Adam, and Brad, using it at DevCycle and how you've used it to build different things and where you find value in it. So I suppose at a high level, what is WebAssembly and why should people care about it?
Yeah, I can start off there. WebAssembly is basically a memory-safe, sandboxed execution environment that was originally built for bringing sort of lower-level native-like code to the web. And so obviously it's branded as WebAssembly, right? And really WebAssembly has evolved into much more of a cross-platform way of executing code at a near native speed across multiple different environments. So everything from the web to at the edge with serverless environments to in your servers and across multiple different language types. And they're really designed to create small binaries that can be started up really quickly and can be executed at really sort of near native speed with a really tight sort of security and sandbox environment around them. Is kind of the gist of what WebAssembly is.
All right, awesome. So I guess where do you guys want to start with this? Do you want to start by talking about where people might start using WebAssembly, or do you want to start talking about what historically has been done instead of something like WebAssembly?
Yeah, we can get into either of those. So let's probably start with some of the common use cases for WebAssembly, right? And so I think some of the most common ones for WebAssembly have really been bringing functionality to a web browser that maybe didn't exist natively, right? And so you think of something like Figma. So Figma, for those who don't know, it's a design tool that allows you to basically do your full design workflow in a browser-based environment, and that is primarily powered through a bunch of WebAssembly libraries behind the scenes. If you want to do deep data analysis or run things like you might run in Python or R and sort of data analysis tool chains, there's lots of that type of stuff you can do with WebAssembly within the browsers. And then also games. So I think a bunch of people have seen on Hacker News, you can run Doom in your browser or things like that, like old school games. All of those are basically just people compiling C or C++ code bases into WebAssembly and loading it into your browser runtime and letting you sort of run games in your browser. And but really, I think where the energy behind WebAssembly is coming is creating that portable cross-platform binary that can be executed either in the browser, but in a lot of cases now in the server side or at the edge. So edge computing is really starting to pick up around WebAssembly because you can start up a WebAssembly runtime in nanoseconds, maybe milliseconds in most cases, depending on how big your binary is, and really scale your edge computing really, really fast up and down. And so there's lots of momentum behind using WebAssembly at the edge. And we're using it at the edge. We're also using it for SDKs across a bunch of different server-side languages.
So I'm assuming the fact that you can run this at the edge and do these other things are the reason why, like when you talk about Figma and some of these tools, theoretically, I assume they could be built with JavaScript. I don't know how performant they'd be, but theoretically, you should be able to build pretty much any software with JavaScript. So would that be the reasoning there that it's not just the fact that JavaScript could have done it; it's the fact that you could also deploy this on the edge and do all that extra stuff. Sorry, I feel like I botched that a bit in explaining it. So I guess what I'm trying to get at is what do you think the main motivation is that caused people to switch from like trying to rewrite all these libraries in JavaScript to WebAssembly? And I think what you were saying is all the edge computing and stuff is the main factor there. Is that accurate?
Well, I think there's also like a performance aspect to it as well. Like as you were mentioning, like Figma could have been written in JavaScript, but like really it actually couldn't have been because like you just would never be able to write something as complicated as Figma with like as many sort of like low level computations that have to go on in just like plain JavaScript. Like it just wouldn't be fast enough. Like WebAssembly kind of gives you like an environment to execute your code in that's like sort of like closer to the actual hardware. So it's like it's easier to write performant applications. And for things like Figma, you're dealing with like huge amounts of like data being moved around and shuffled and like transformed and that sort of thing. And those kinds of operations, like you just can't write them efficiently in JavaScript. You need some sort of like compiled layer to do that. So I think that's like another big benefit of it.
So the amazing thing about JavaScript is that JavaScript can actually be really fast because V8 is like this magic piece of software. Like if you haven't looked at the internals of like how V8 works and how it optimizes JavaScript code, it really is like a pretty magic piece of software that I'm sure hundreds of millions of like developer hours have gone into making this amazing, amazing thing. And so V8 can get your JavaScript really, really fast, like very close to native, but because it's a JIT compiler, it takes time to get there, right? Like, so the first execution of your JavaScript code will be kind of slow. And then as the JIT compiler and V8 and SpiderMonkey and all these other engines sort of kick in and compile your JavaScript code into lower and lower levels, your code gets faster and faster. But with WebAssembly, you can basically compile down to that sort of near native speed, like running the same code in Go or C# or Rust or C++ or something like that. You can get a similar performance level right out of the box by sort of compiling your target to WebAssembly and executing that in the browser environment.
Okay, so this is Go time, obviously. So it stands to reason that a lot of our listeners want to use Go with WebAssembly if they're listening. So I guess to get started, how would somebody get started using WebAssembly with Go?
Yeah, so there's two ways. So you can either compile your existing Go code to WebAssembly. And so there's a couple projects out there around that. And you can actually create portable code out of your Go code. So if you actually want to like, say, take this Go library you have and execute it at the edge or execute in a web environment or even a mobile environment, because WebAssembly can be run in mobile, you can take that Go code and package it into a WebAssembly binary. It's a pretty simple thing to do. It's a compiler target. You can Google it. The one advice I have there is that the standard sort of compilation creates pretty large binaries, like multi-megabyte binaries, which don't sound that big, but actually in the WebAssembly world, you want to get down to like, I don't know, single-digit kilobyte binaries so that they can be downloaded really quickly and executed and loaded into the runtime really quickly. So the main advice I have for anyone looking to do that is to use TinyGo as sort of the layer. I mean, it reduces the binary size a lot on your output, and obviously restricts what you can use within Go. But my advice there for anyone looking to do that is to use TinyGo. And then if you're looking to take WebAssembly code that you've maybe written in another language and execute it within Go, the Wasm time runtimes are what we highly recommend. They're the main supported sort of runtimes by the Bytecode Alliance, which is the open source alliance behind WebAssembly, and are well supported and well battle tested at this point. And those are sort of the runtimes that we're trying to use ourselves in all of our SDKs across all of our different languages.
So when it comes time to actually write the code like this, is it going to, I'm trying to think of an example. Like there's a couple libraries out there that allow you to write Go code that like basically generates React or something like that. And in a lot of those, you end up having to write very specific code. It doesn't really feel like Go code. It feels like you're writing like Go merged with React or something like that. So when you're doing WebAssembly, do you have to like drastically think about how you're thinking about Go code, or does it really feel like you're writing Go code?
Yeah, I think that's where we can get into the challenges with WebAssembly. So you really have to define your interface. And I think that's the biggest challenge of like working with WebAssembly right now is you really have to understand sort of the interface between your native code and your WebAssembly code to build sort of those features well. And I know Adam could probably jump into this a bit, but that's where we've faced the biggest challenges. If you want to get performance WebAssembly code, it's really great at doing CPU cycles. It's not so great at sort of managing memory and transferring data in and out of between your native code and the WebAssembly code. So that's where you really have to be careful and think about sort of how much data you're passing into your WebAssembly runtimes and how much data you're sort of fetching out of it and how you optimize that path.
Yeah, like I guess just to jump in here, like one issue that we really ran into was that it's not really possible to exchange sort of like complex data structures in memory between like some native layer like Go and like a WebAssembly layer. And really you basically have to think about like how can I pass my data in a way that can be like serialized and deserialized as efficiently as possible, because you can't do something like take like an instance of a class or something and then just like use it directly in your Wasm side. But what you can do is figure out how to like turn that class into some like representation in memory that you know how to read on the WebAssembly side. So there isn't sort of like a direct one-to-one of like this object becomes this object in WebAssembly. But instead there's kind of like, turn this into like for example, in our case, we ended up using protobuf as like a serializer, but there's other examples of how to do that. Like I think Google has like a frame buffer type of library. We originally were using JSON, but it was a lot slower obviously than protobuf. So there's different strategies that people use to just kind of like efficiently shuffle data back and forth when they're executing their Wasm modules.
And it's really optimized like if you're just dealing with like binary data. So like there's a lot of examples of like using WebAssembly for like video encoding or audio filtering, or like I wouldn't be surprised if like the tool we're using today, what Riverside is using some WebAssembly modules behind the scene to do a lot of the audio filtering and video encoding and types of things in the browser level. So where you're just dealing with sort of like structured binary data that is easily passed between two systems, between sort of like the JavaScript side or the Go side and the WebAssembly side. So in those use cases, there's a lot of like image processing WebAssembly binaries out there that let you sort of do image analysis or image sort of like filtering and things like that within your browser and do it much faster than you could do it within JavaScript by just looking at sort of the binary data and passing that buffer between your different environments.
So when Brad reached out to me talking about WebAssembly, he said that you guys had some pretty interesting use cases for WebAssembly at DevCycle. So can you share a little bit about what you guys are building that required the use of WebAssembly? Or maybe not required, but benefited from it.
Yeah, happy to do so. So at DevCycle, we're building a feature management tool. So we're building a feature flagging tool that needs to work across many SDKs and many different environments, right? And you can imagine for a feature flagging tool, like we want to be able to support as many different customers that come to us and want to use our software. And to do that with a small team either requires you creating lots of custom SDKs for all the different languages under the sun, or you can figure out a way to use the same code base across multiple environments. And that's really where we came to WebAssembly. And we've been playing around with it for a couple of years with our previous products and really took the dive with DevCycle to say, okay, we're going to create one common WebAssembly sort of code base that has all of our core business logic, all of our logic about how we decide which users should be bucketed into which feature flag and decide sort of the rollouts and all the sort of important business decisions that we need this piece of code to be super battle hardened, to have every test we can think of being run against it frequently and be as solid as possible. And so by using WebAssembly, it allowed us to create a really battle hardened library that we could then share across everywhere we need it. So we're using that WebAssembly library in our workers that are running our scalable APIs that run within Cloudflare's Edge worker environment. And then we're using that same WebAssembly code in all of our server-side SDKs. So everything from Go to Java to Node.js to where else are we using? C#, I think Python and a couple others are coming soon. And so all the major sort of server-side languages that we need to support as a feature flagging platform, we can now be really confident that we can build those SDKs quickly, and we can ensure that they all work as we expect because we're using basically the same core code across all those SDKs and across our APIs. So it's brought in a ton of business value for us and really reduced the amount of code that we've had to write, basically.
I'm curious when the decision was being made. It was before my time at DevCycle, but when the decision was being made to go with Wasm, like what was the community like? What was the maturity of Wasm in general? And like we hadn't quite seen. Like Figma is a really good example of a company that's using Wasm at incredible scale, right? To great benefit. But Wasm is like WebAssembly is still pretty new, and it's still kind of figuring itself out, and it's still kind of figuring out its place in the ecosystem. So what was the community like when you were deciding, when DevCycle was deciding to opt into it so hard?
Adam, do you want to jump in there?
Sure. Yeah. I mean, like, I think one thing that's been kind of interesting is that we've sort of felt like we've been a bit on like the bleeding edge of using this stuff the entire time that we've been like trying to employ it in our SDKs. And I would say that like when we first started using it, I mean, there's a pretty decently sized community around it, but a lot of the like specific tooling that we were using was like, I would say fairly kind of like fresh. And so it's kind of been interesting because we've sort of been able to like watch it grow with our usage of it. Like one of the main sort of tools that we use is assembly script. And so that's like a language that basically looks sort of like TypeScript or like the typed version of JavaScript, TypeScript, but it compiles to basically like a WebAssembly module. And that language was like pretty new when we started using it. Like I think it had only been out for like maybe less than a year. And sort of like as we've been using it, we've seen it like vastly improve. We've seen the community grow like quite a lot. And we've been like pretty active in their Discord. They have like a really good community in there, people that like answer your questions if you have issues with it. But yeah, so it's been really interesting to kind of like sort of like see the excitement and the like momentum growing behind using this ecosystem.
And I would say like the ecosystem for people using WebAssembly in the browsers has gotten pretty mature. Like I think browser support for WebAssembly has been in place for a long time now. I don't know exactly the number of years off the top of my head, but it's many years. And WebAssembly, actually, I think I was talking to some of the folks behind WebAssembly last week at KubeCon in Amsterdam, and I think it was started around 12 years ago or 10 years ago. Like it's been around a lot longer than most people think, but it was really originally about bringing your sort of like more lower level code bases, like your C++ code bases, your Go, your Rust code bases, into being able to execute them in a browser environment. But really sort of where the community is going is expanding beyond that, which is bringing sort of the power of this very secure, small runtime to other places like your server-side use cases, your edge runtimes, things like that. And that's really sort of where the community has started to grow. And there's a bunch of new startups that I got to talk to last week who are really trying to basically like replace Docker containers in a lot of ways with WebAssembly runtimes for things like Kubernetes and at the edge. So it's a really exciting space, and the community is growing and accelerating really quickly here.
Yeah, I found it very interesting how, like you said, the original goal of this was to, let's bring some Unreal Engine, I think, was one of the things that they compiled via Inscription and had it running in the browser. It was like, this is awesome. That was even before we had WebAssembly, and how like the whole goal of that was like, okay, let's move it into the browser. And no one kind of thought of at the time, I don't think anybody really thought of it, that like, wow, the browser is actually this incredibly sandboxed environment, and we have not really thought about that because, like, a lot of backend engineers don't pay a whole lot of attention to front end. So it's just like, oh yeah, the browser just kind of works, but it's incredibly robust when it comes to sandboxing, and WebAssembly had to do that as well. So that's one of the things I always found incredible about WebAssembly is it's like, oh yeah, we've been trying to do all of the sandboxing on the server side, and it's just been, we've tried. It winds up being pretty messy outside of virtual machines. So I found that whole arc and that whole story kind of incredible in of itself. You mentioned using assembly script. I'm just curious, like, what's been the experience actually writing code, like writing, WebAssembly in assembly script? Because I've heard it can be a bit rough because it's a bit like TypeScript, but there's a lot of parts of it that aren't. And I know that WebAssembly also, like, you basically get nothing. Like it's just, here's a box, you can run some code in it, but don't expect it to be like an actual computer.
Yeah, I mean, I would say like from our experience, like there's definitely a lot of pitfalls with using it. And I think it's maybe a bit deceptive when you first start learning it, how similar it can look to TypeScript, because under the hood, it really doesn't work like TypeScript at all, obviously. And so you really have to kind of like like, especially when you have like, when you're sensitive to performance or when you're sensitive to things like that, like you really have to start like looking at like the actual output that it's giving you and trying to figure out like what your code is ultimately doing inside of the Wasm environment, because you can very easily write like extremely inefficient code that would not seem inefficient if you were just running in a JavaScript environment. And I think Jonathan mentioned earlier, like the V8 like JIT compiler is like really good at sort of like, once it executes some code path that might not be efficient the first time, it like really quickly optimizes it so that the next time it runs, it can be a lot faster. None of that is the case in the assembly script world. So if you write code that like might not have seemed slow in TypeScript, it will end up being slow in AssemblyScript. And we also found like the further we got into it, the more we sort of had to understand the underlying like memory structure of like how it allocates memory for the various different kinds of like standard objects that you can use. Like we had to kind of figure out like how do strings work, like how do class instantiations work, like where does the garbage collector kick in? Like there's kind of like a lot of factors involved, which we got into more and more as we were trying to optimize performance. So it was really easy to get something going that like worked and passed all of our unit tests. But once we started to like profile it and benchmark it, that's when we started to realize like, oh, a lot of the assumptions we've made about like how we can write this are actually like not true. And we need to start sort of like rethinking some of it to make it performant.
Yeah, for context, like we were coming from a TypeScript code base that basically wanted to make work in WebAssembly, right? And so it was kind of a natural choice, right? And so basically we took that TypeScript code base and we basically had to go in and basically change all the higher level types to lower level primitive types, right? And then we had to remove things like you can't do closures or things like that in assembly scripts. So we had to refactor a bunch of the code back down to like lower level primitives, sort of going back in time a little bit to simpler times. And we were able to convert our fairly large code base to AssemblyScript in under a week and getting it passing all of our tests and functional. And so it really, I think it made a big impression on us and how quickly we were able to get something going. But yeah, as we get into the project we've been working on lately, which has been optimizing our Go SDK to sort of the nanosecond level, there's definitely a lot of roadblocks that we ran into along the way with the AssemblyScript side of that.
Yeah, I was hoping we could dig into that a little bit further. I think DevCycle's use case is sort of unique in this space, and Jonathan, you're saying, you're kind of scoping this a bit. Like we're talking about ultra low, like nanosecond level latency. We're talking about edge computing. We're talking about running things in the browser as close to the user as possible. And so I think the DevCycle use case is far beyond just the cross compilation, the shared binaries sort of benefits of WebAssembly, and really what we're talking about is like super micro optimizations and very large scale performance, right? If you look at sort of how DevCycle infrastructure operates. So I'm hoping if we can dig into sort of let's get into the gritty sort of technical details of like what was it like? How did you go from sort of WebAssembly code that ran to like how do we make it run really, really fast, specifically in a Go runtime, right?
Yeah, I'll provide some context to the optimization problem, then Adam can dive into some of the details there. But basically, we were basically challenged by a new customer who is running a global CDN network, and that global CDN is built upon a Go code base. And we're like, okay, this is a real challenge for us. Like we have to take this challenge to optimize our WebAssembly code as much as possible so we can make as little impact to the performance of their CDN code running Go and evaluating, say, tens to hundreds of flags at any given time. So that was sort of the challenge put in front of us. And we kind of naively said, okay, let's take it on and let's dig into every single little detail within the WebAssembly code and start looking at sort of like everything we can do to sort of optimize the performance of it. And yeah, there's definitely some interesting things we found along the way. I don't know, Adam, if you want to start with like where we started from, because we didn't start from a good place, but we got to somewhere pretty good by the end.
Yeah, I mean, as I kind of alluded to earlier, like our goal originally with this was just to get something working at feature parity with our original TypeScript code. So we weren't really super concerned with actually how performant it was. And it was only once we started to dig into the performance metrics that we realized like how far we needed to go from there. So our initial performance metrics, we were measuring in terms of evaluations of a user against a variable. So the DevCycle SDK, you're basically asking it for what is the value of this variable given this user data. That's sort of the idea of a feature flagging platform. It's like, given this user, what value of this variable do they get? And in our case, each one of those evaluations in the very first version of this code was over like a couple of milliseconds, which is really, really slow. Like we're talking about like a CDN here that's like they're targeting like 10 to 15 milliseconds in total for like their entire request handler, which might evaluate like 10 or 100 DevCycle variables, where each one of them would be taking 2 to 3 milliseconds in the original code. So obviously that was like an untenable like performance level. So a lot of the initial work that we did was essentially just to like reduce the amount of data that was being passed over that module boundary. So we talked about this earlier, how it's not possible to just like directly share like rich objects between your host and your Wasm code. So we had all these requirements to like pass like a structured set of user data and a structured set of like configuration data that was received from the server, and then tell Wasm to basically give us the answer of like, what is this variable value supposed to be? So a lot of the initial work was kind of like, okay, how can we like cut down to like the bare minimum of like the data that we actually need to pass across that boundary? And it turned out we were passing a lot of data that was not necessary for that particular operation. So once we cut that down, that got us like much more into the ballpark, where it was literally like 2 milliseconds to like 70 microseconds, which was like a huge improvement to start with. But 70 microseconds was still way too slow, because to sort of set like a, I guess like a ground truth here, like we benchmark some of our competitors' SDKs, and like their execution times were down in like the 1,000 to like 10,000 nanosecond per op range, whereas ours was up in like the 70,000 nanoseconds, 70 microseconds. So yeah, a lot of what we ended up doing was kind of like avoiding like allocating new memory and sort of like sharing the memory between the host and the Wasm module more efficiently. So it turned out that like, especially in assembly script, like asking it to allocate new memory can be really slow, because assembly script tries to give you this like sort of easy to use garbage collector where it'll just make sure that things are being cleaned up properly, but it's like a fairly naive algorithm that they use. And so it ends up adding a lot of time every time you need to like allocate new memory for things. So one of the major optimizations we did was basically to say like, okay, let's sort of like create a buffer in memory that is like the scratch space to like write any data that we need to pass across the boundary to, rather than what we were doing before, which was like allocating that entire buffer every single time and basically saying like, here's your new buffer, I'm going to write the data into this buffer, now you should read from this buffer, and this is your data that you need to deal with. So instead we said, here is this like static buffer of a fixed length, and we're just going to like write into some portion of it and then tell you like where to read from. And so it's already allocated, it's already fast. All you need to do is just like read the bytes to get your information. So yeah, that was like the majority of the work that we were doing was kind of things around that. I can keep going, but I don't know if you want to ask any questions.
Well, I'm curious from the Go perspective. Like I think the numbers are obviously impressive and interesting. How are you measuring these things, right? Because you're measuring it from a Go runtime point of view. You're not measuring it as a WebAssembly project. What tools are you using out of the gate to even arrive at these measurements?
Yeah, so we actually had a lot of different tools we ended up using for different reasons. So these numbers that I'm sort of rattling off here were all based on just running a Go bench test, where it was essentially just like evaluating a variable as fast as possible in like a single thread and just saying like, okay, like how quick is this operation? And at the end, it would just spit out, like time per op. So that was sort of like where we were getting our initial numbers from. We realized as we got further into it that there was sort of like more factors involved, like especially when you start to deal with multi-threading, which is obviously important for like a Go web server. Like you can't have like just like the single threaded thing sitting here being like the bottleneck for all of your stuff. So that sort of like changed the nature of how we needed to measure things. But outside of sort of like just measuring the times per op, we were also sort of digging into like how long are the actual calls inside of Wasm taking, and like what is slow inside of those calls. And that's not something that was easy to measure on the Go side, because we were using things like pprof and basically like spitting out like a CPU profile and going to look at it. And like, as far as like Go is concerned, everything that happens past the WebAssembly module boundary is just like a black box. So we just had this giant box on our pprof output that was like 20, 30 microseconds. And it's like, well, what's going on in there? Like, how are we supposed to find that out? So it turned out that Node, like Node.js, has sort of like really good native support for WebAssembly, which includes actually outputting CPU profiling like information for the actual WebAssembly calls that are being made, down to like the actual like executions that are happening. So we were able to basically take the same module we were testing on Go, stick it into our like Node SDK, and start running some benchmarking there, collecting CPU profiles from that. So like the Chrome browser has like basically a debugging tool that you can just attach directly to a Node process. So we were just kind of capturing CPU profiles from the same sort of test that we were doing on the Go side. And once we were doing that, we could now start to see like, okay, here's like the particular call inside of the WebAssembly code that's slow, or like, here's where we need to like focus our time to do some optimization work. And I think we were able to save like another like 20 or 30 microseconds of time just from like doing that, basically, like just kind of looking for like, where are we like inefficiently allocating stuff? Where are we like maybe duplicating some calls that we didn't need to be duplicating? Like, where could we sort of like transform the configuration we're getting from the server before we need to use it, so that it's like in a more efficient form for the code to iterate over. There's a lot of sort of like revelations that came from that. So that was an interesting investigation as well. And then we also were getting into a bit of like memory size issues as well, where it's like sort of like how much memory is it allocating? Are there memory leaks? That sort of thing. And so for that, we found some tooling that actually will like plug into the assembly script compiler and can give you a like really detailed output of like what is on the heap right now and what's been allocated. And we were able to sort of like do the standard like comparing of two heap dumps to sort of say like, oh, like there's maybe like a leak happening here, or like this is like allocating like way too much memory. And we could kind of start to dig into some of that as well. So it was actually like a pretty good experience overall to sort of be able to use all those tools to dig into some of this stuff.
So when you said you were using Node to sort of dig into the WebAssembly side and to actually trace what was taking a while. Do you see that as something that eventually like WebAssembly itself will have tooling around that, so that you don't have to sort of jump from language to language to test that? Or is that something that would have been hard to do without something calling the WebAssembly directly?
Yeah, I think it's just that like the V8 runtime for WebAssembly is the most mature runtime, right? So they have those development tools built up, and I'm sure that the Wasm time by Code Alliance team are definitely working on similar types of outputs for all the different runtimes that they support. But yeah, the common recommendation is, if you really want to get that low level optimization, plugging it into some type of browser engine that has Wasm support is the best way to get that low level sort of profiling information. And obviously Node, being that it just runs on V8, is probably the easiest way from like a server side use case to get that data.
When you guys were like actually doing all these optimizations, did you find that a lot of other companies were doing similar things? Because you said that like when you started, it was pretty like WebAssembly wasn't adopted by a lot of people. So were you kind of like in the dark figuring this out on your own, or were there other people you could talk with and exchange ideas with?
I guess we haven't really come across anybody that's trying to do what we're doing, which is like using a WebAssembly module to just create like a reusable block of code in like SDKs and also on a server and also like everywhere else. I'm sure there are people that are doing it. I'm not aware of them, but I'm sure they're out there. If you're listening, give us a ring. But I think like I mentioned this earlier, but like the assembly script community was really helpful to us. Like they have a Discord. We joined. The creators of the language are in there pretty much every day. They've jumped in on some of our questions. So it's definitely pointed us in the right direction. And we pretty much wouldn't have been able to get where we are without their help. So we're really like appreciative of that. But yeah, there was kind of a lot of, like fumbling around in the dark, just like trying things, trying to like figure out what was going on. But I would say, we're in a much better place now than we were when we started. Like I think we understand how this stuff works a lot more than when we first went down this path. So
yeah. I would also say that most teams who are trying to do sort of high performant WebAssembly code bases are likely starting with a lower level language like C++ or Rust or something like that as their target compiling to WebAssembly. So if you're starting a brand new fresh project and not coming with an existing sort of TypeScript code base like we were, I would definitely recommend sort of starting with one of those probably two languages that are sort of I would say there's a much larger community around Rust and C++ of compiling to WebAssembly than there is trying to compile TypeScript code to WebAssembly. So that would be my advice. And you can also go down the route of using Go. From people I've talked to, the Go to WebAssembly conversion doesn't seem as efficient as Rust and C++. It's probably at a similar efficiency level of where the assembly script code is. So you're not going to get as purely optimized code as you would with C++ or Rust, but I'm sure there's lots of Go folks out there who are probably listening to this and shaking their fists at me like, no, I'm working on that optimization. And so I'm sure it's going to get better over time. So, but yeah, it definitely start with like a lower level language for if you're trying to do something very latency sensitive. And I think over time, we're definitely looking to move to something that starts off at a lower level and can be optimized more directly than our assembly script code is. So I think we will sort of migrate to something like that over the coming months or years.
Just to make sure I understood correctly, I believe you said that WebAssembly has like a garbage collector and that you guys were not using it because it was just slow with what you were doing and you needed like to have that scratch space. Is that what contributed to like the memory leaks and that sort of stuff then?
Yeah, there's a couple things there. So WebAssembly itself at the moment doesn't have a garbage collector as far as I know. Although I think there's like a proposal that they're working on to sort of like standardize like how a garbage collector should work. But at the moment, like it's basically up to whatever you're using to like, output to WebAssembly to figure it out. So in this case, like the garbage collector was actually implemented by the assembly script, like compiler. And essentially like their implementation turned out to be the majority of the slowness once we had like trimmed away like everything else we could do. We sort of got down to like, okay, now we're basically just trying to like reduce the number of memory allocations because every call to like allocate new memory was like sort of showing up on our profiles being like, okay, that's pretty slow. There's also some interesting like work we were doing there to kind of like tweak there's like a couple of variables you can tweak in the garbage collector algorithm to try and sort of like improve like how often does it run, like how long does it interrupt for, and try to like smooth out the lines a little bit, because we were also measuring like P50 execution time compared to P99 execution time. We were seeing like huge discrepancies there, which turned out to be like a garbage collection issue where basically like anytime the garbage collector decided to interrupt, it would like triple or quadruple the like execution time of that specific call. And we needed to kind of like bring those numbers closer together. So we were sort of playing around with the garbage collection numbers to try and figure out if we could tighten that band a little bit. In the case of the memory leak thing, so the one instance of that happening that was actually kind of interesting was sort of what caused us to go down that route of using that tool I mentioned earlier, which like analyzes, it's like a plugin for assembly script that like analyzes the heap and tells you like what's been allocated. And we were trying to basically use that output to figure out like what's leaking. But what was really interesting is when we used that, we weren't seeing any new allocations like or any like major growth happening in the actual like addressable heap memory space. But what we were seeing was the overall, so like the way that the WebAssembly works like in Wasm time and probably everywhere else is that there's like a certain fixed amount of like linear memory that it gets allocated for execution. And when it starts to run out of that linear memory, it will grow the amount of memory that it's like allowed to use. I think that might actually be implemented by assembly script, but it like doubles the amount of memory. And so what we were seeing was like this like linear memory size was growing and it kept getting bigger and bigger the longer we ran it for. But meanwhile, the heap was like, well, I don't have any new stuff going on. Like, I don't, and so we had to figure out sort of like, where is this memory growth coming from? Like, why does it think it needs to grow its linear memory when its actual like heap size is still really small? And it turned out that it was like a bug in like one of the libraries we were using. And this kind of gets back to like the fact that we're like a bit on the bleeding edge here, where we're like using libraries that are like really, really new, some of which are like not super production hardened. And in this case, like this library was using this concept in assembly script called like an unmanaged class, which basically like skips all of the garbage collection stuff and expects that you're going to like keep track of its references. But the library wasn't actually keeping track of the references to those classes. So it wasn't showing up in the heap because the garbage collector had no idea that it existed. The library also forgot about it. So it was basically just like filling up a whole bunch of memory space with like instances of this unmanaged class that was never getting cleaned up. And so that was kind of like an interesting investigation, because we basically like, ended up zeroing in on this library being like, oh, okay, so because they're allocating this unmanaged class, like it's not going to show up in any of our tooling. And so we ended up sort of like collaborating with the author to get that fixed, and the problem went away.
Yeah, and for some background there on garbage collection in WebAssembly is it's currently the responsibility of like the runtime within WebAssembly to manage its own garbage. And so, for example, assembly script has its own garbage collector, as you said, and if you're using Go, for example, compiling to WebAssembly, it would sort of bundle in a garbage collector there. There is a really exciting proposal that we're engaged in that would actually expose the garbage collection to the host runtime. So, for example, if you're running Wasm time in the future within Go, the Go native garbage collector could manage all the pointers and references for all the allocations made within the WebAssembly. Or, for example, if you're running in the web or in Node, the V8 sort of garbage collector could manage all those references for you, which would be way more efficient than trying to bundle in like a garbage collector into WebAssembly like we have to do right now. So that's one of the many proposals that we're keeping a close eye on and are probably going to be early adopters of.
I assume that means if somebody's coming from like C, C++ over to and converting to WebAssembly or compiling to it, at that point, it's going to be the same as normal C++ where they're managing all that on their own. So is that one of the reasons why like you see C++ being a little bit more bleeding edge as far as like WebAssembly performance?
Yeah, for sure. Yeah, if you're managing your own memory, then you can definitely not pay the garbage collection tax and get a much more performant WebAssembly code base for sure. But then you have to manage it all.
Sort of along a similar line, I wanted to ask about the concurrency model difference, right? Because like a big reason for adopting Go on server side in general is for concurrency and multi-threading support and Go routine environments and that sort of thing. But obviously there's trade-offs when you're going into like a WebAssembly built core. How did you approach that? And what do you think needs to happen for that to be performant going forward?
Yeah, I mean, like basically the current state of WebAssembly is that and my knowledge might be out of date here, but like there's also a proposal for multi-threading support that hasn't quite landed yet. And for that reason, assembly script doesn't support any form of multi-threading either. So what that means is basically like for us to safely call our WebAssembly module, we essentially had to like put a mutex around any call to it to make sure that like we weren't sort of like corrupting the memory state by having like multiple Go routines accessing it at the same time. Problem with that is that it obviously creates this sort of like single bottleneck for any web server that's trying to serve, like thousands of requests concurrently. And it's dealing with like this little WebAssembly module that like every time it's asking for a variable value, the WebAssembly module is like, sorry, hold on. Yeah, I'm doing something else from somebody else. So we ended up solving this in the SDK by basically creating like multiple instances of the WebAssembly module and then just kind of like shuffling between them. So whenever like proper multi-threading support lands, we're definitely going to like integrate that into the SDK. But sort of in lieu of that, we sort of ended up on this solution where we have, I guess it's called like an object pool, where you can basically borrow an instance of the WebAssembly module and then do some work with it and then return it to the pool. And so the SDK lets you configure the like number of those objects that you have. By default, it's basically like the number of like max Go procs. And you essentially like every time the SDK is asked to get a variable value, it's just borrowing one of these WebAssembly modules from this pool, doing its thing, and then returning it back to the pool. So that was sort of like our workaround for that. And it basically unlocked better concurrent performance. There were a couple challenges there as well with like the WebAssembly sort of needing to be kept up to date with like the latest configuration from the server. And we had to kind of make sure that like across that whole pool, every instance of the WebAssembly had the latest configuration that had just come in. So we had to sort of like set up this system of like taking some of these objects like out of rotation so that we could like kind of update their configuration behind the scenes and then return them basically back to like active duty once the configuration was up to date. So there was a little bit of like interesting kind of like juggling going on there, but the solution seems to work fairly well.
Is that something you had to actually set up and manage in every SDK individually? So like if you're writing a Go SDK, you'd have to set that up there. And if you're writing like a Rust SDK, you'd have to set that up there.
Yeah, basically it would end up being language dependent. So I guess the downside of this is that like with the original goal of WebAssembly kind of making it really easy to write all of our SDKs across all of our different platforms, like as we got further and further down the performance path, we started to realize that there's like more and more sort of like platform specific code we had to write to get it to perform the way we wanted it to. So another example of that is the protobuf serialization that I mentioned earlier. So to pass data back and forth across the WebAssembly boundary in a performant way, we switched from JSON to protobuf. And in order to do like the protobuf serialization, we basically needed to implement like a protobuf serializer and deserializer, or use like an off the shelf library in every SDK that was going to use protobuf. So we did keep around like some of the old interfaces. So the Wasm module still can use JSON, and it doesn't need to have multi-threading support depending on the platform. Like obviously in Python, like everything is single threaded anyway. So it's like on Python, you don't need to really like worry about building multi-threading support. And also like in some platforms, like the performance is already kind of like good enough. Whereas in Go, we're thinking like it has like higher performance requirements basically. So
I think that's the important point, is that like for like 99% of use cases, the single threaded performance of the Wasm code has gotten so good, like how far we optimize it, that like a mutex lock around it like doesn't affect performance in a very parallelized environment at all. But for this specific use case where we're dealing with an extremely high load CDN server that's running this Go SDK, in that specific scenario with such high request count, in that scenario we definitely needed this optimization, and it helped bring down our P50 and P99 times by a lot once we implemented it. But for like 99% of use cases, the like single threaded performance of the WebAssembly code is so good now that like you don't really notice a difference for most SDKs.
Hello, friends. This is Jared here to tell you about Changelog++. Over the years, many of our most diehard listeners have asked us for ways they can support our work here at Changelog. We didn't have an answer for them for a long time, but finally, we created Changelog++, a membership you can join to directly support our work. As a thank you, we save you some time with an ad-free feed, sprinkle in bonuses like extended episodes, and give you first access to the new stuff we dream up. Learn all about it at changelog.com/++. You'll also find the link in your chapter data and show notes. Once again, that's changelog.com/++. Check it out. We'd love to have you with us.
I actually think you should probably leave.
Okay, it's time for our unpopular opinions. It does not have to be tech related, just something you think is going to be an unpopular opinion. We will then set it up as a Twitter poll and let our audience decide if they think it's actually unpopular or not. So would anybody like to start first?
Yeah, I'll go for it. My unpopular opinion is that WebAssembly runtimes will replace container-based runtimes by 2030. The advantages of WebAssembly with its tight security model, its very fast boot up time, scalability at the edge with much smaller footprints, its portability across environments will really drive a shift away from container-based runtimes for things like Kubernetes and edge workloads by 2030. And there's a ton of energy around making this happen within the WebAssembly community.
What do you think is the largest barrier to getting there now?
Good question. Yeah, I would say likely language, like language support, profiling, and tooling. I think as we've talked about today a lot, like getting to a point where you can optimize and profile the WebAssembly a lot easier, I think is a big thing. And the standardization. So there's a lot of really exciting changes to WebAssembly that are coming along. I think we've talked about a couple of them already around multi-threading support and native garbage collection support. One of the big changes that are coming to WebAssembly is called the component model, which is a way to standardize the communication across multiple WebAssembly components, and they can talk to each other and really sort of like make your code a lot more componentized and in smaller chunks. And so that's a big effort that the community is working on to drive towards sort of replacing larger containers in these sort of Kubernetes and edge workloads. So I think those are the big things that if the WebAssembly community can get sort of those big changes that are coming, the component model, multi-threading, garbage collection support, and many other things down, then I think we'll be on that path, and we'll see some big companies start up around this space in the coming years.
I think it's funny because like Jonathan, like we've talked about this a lot, and I think my unpopular opinion would be the opposite of that, because I don't know, maybe more on time frame, like sure, maybe possibly, but I think the lift required is so large. Do you think that something like assembly script is crucial for that, right, as sort of like this core sort of native entry point?
I think a more approachable, higher level language is important as an entry point. I think that's one of the challenges with WebAssembly right now, is that the best environments are lower level environments, like things like using Rust or C++, right? And so there's actually a good amount of momentum around running JavaScript or TypeScript in WebAssembly, but by bundling in SpiderMonkey, which is Firefox's JavaScript engine, into your WebAssembly runtime. And they've been able to get that working in a couple megabytes. So you basically have the full sort of SpiderMonkey runtime running within WebAssembly, running your JavaScript or compiled TypeScript code in that. And that's kind of one of their, for a lot of these Wasm Cloud or Wasm Edge companies, one of the big entry points that they're talking about. But yeah, I would say getting a higher level language that executes really efficiently in Wasm is probably one of the biggest barriers to that.
From the other side of things, I'm wondering as well, like, do you see, well, I guess I should say, there's a lot of pressure from the other side, I would say, as well, of like VMs and hypervisors becoming like super fast, like with Firecracker and all of that. Do you see like maybe a merging of those technologies so you can get the security benefits of virtual machines in like the speed and all the other benefits of Wasm?
Yeah, like, don't get me wrong, those VMs have gotten very good over many years, and we've been relying on them for a lot of our high scale systems. But yeah, I think there's just like an order of magnitude difference between the size of containers. Like, yeah, you can optimize your size of your containers to be pretty small, like tens of megabytes size, right? But WebAssembly is at its core designed to be more portable than that, where you're talking about tens of kilobytes instead of tens of megabytes. And the boot up times can be measured in sort of microseconds instead of milliseconds or tens of milliseconds or even seconds for containers, right? And so there's just like an order of magnitude change there by using WebAssembly that I think is going to be really hard for a lot of containerized systems to match. Like, you can think about a big platform running at the edge at scale where, say for us, like, for our use case, like, we have a lot of SDKs that hit our edge APIs, and we have certain customers that say are big mobile apps, right? And they may send out a push notification and get hundreds of thousands of people or even millions of people who all open their app at like exactly the same time. When that like sports score or that big news event lands on their phone, they're opening their app at exactly the same time. And we see massive delusions of traffic, like literally 100 times our steady state traffic hit our edge endpoints in those points in time. And because we're using these edge platforms, they're able to spin up like thousands of runtimes of Wasm and edge runtimes in milliseconds to serve that traffic. And trying to do that with VMs is possible, but there's a lot more latency in that tool chain. So that's why I think like the power of not only like the really tight security model, but like the boot up times, the small size of the Wasm modules really can power that. And for certain use cases make a lot of sense. Like, I'm not going to say it's going to replace every use case. Like, it's clearly not, right? But for certain like high performance, latency sensitive use cases, like trying to deliver feature flags globally to mobile apps and web apps around the world, like, that is our use case, and it's like definitely very applicable to this problem.
So that would definitely mean that in that case, the way I would put it is I feel like the current setup with like Docker containers or whatever else that are a little bit slower, but they work for probably 90% of use cases. Maybe not. I'm just throwing that as a random number out, but they work for some big chunk of use cases. Mm-hmm. And the WebAssembly version that you're saying would replace it. Essentially, the speed benefits and all those things, there's going to be a huge chunk of people who wouldn't actually care as much about that necessarily. So I'm assuming for that to happen, it would have to become just as easy to use the Wasm replacement for Docker. Like, because that's the only way, at least in my mind, that's the only way I would see that working, is if it became just as easy. And I don't know, do you think it's just as easy now?
Oh, it's definitely not just as easy yet. I think there's definitely a lot of developer tooling work to go to make it easy. Like, we've been using Cloudflare workers, and there's lots of other people like that for edge runtimes that make it super easy to deploy edge runtimes that make that pretty easy. But I think the real benefits come from like the security benefits. So like a WebAssembly module is way tighter in controlling sort of what it has access to through the WASI app interface than a VM is, right? And so for very security conscious companies, I could see it having a lot of value there for certain like mission critical modules of their application. And then there's a lot of cost benefits. Like, one of the reasons why it's a lot cheaper to run your edge workloads in Cloudflare workers or Fastly or Netlify, like any of those edge runtimes, versus something like AWS Lambda, is because the boot up and shutdown times and the sizes of the binaries that they have to manage are way smaller, right? Like, those edge runtimes can start up your your code in milliseconds, if not faster, where like Lambdas and other things like that are more containerized at the edge take a lot longer to spin up. They have a lot higher memory footprints, things like that. And so the cost differences there can be huge. Like we saw a huge cost savings ourselves by like moving to these edge runtimes to run these workloads at scale. Like we obviously, not only do we build SDKs, but we run really high scale sort of APIs at the edge, and there's huge cost advantages to having really small, portable, fast runtimes that can execute all around the world.
Makes sense. All right, Adam and Brad, or Chris, do either of you or any of you have an unpopular opinion you'd like to share? Sounds like no. Everybody's scared to bring an opinion.
I mean, I could come up with an opinion.
I could unleash a bunch, but I don't know there's value going down that road.
I mean, that's what the segment is for. Let's say something spicy.
I mean, we've had some that I'm actually curious. I need to go check if they put it on Twitter yet. The one we had not long ago was when Matt and I were talking with, I think it was Matthew Boyle, who wrote Domain-Driven Design with Golang. His unpopular opinion was that you should be able to bring your laptop into the movie theater and use it while you're watching a movie. And I'm still pretty convinced that one's going to be one of our more unpopular opinions.
I've lots of stories of bringing my laptop into a movie theater because I was on call, and then every time I go into a movie, I get an on-call call. And that happened to me like 3 times in a row in the early days of our first company. So
you might agree with them just so you don't have to leave the movie theater.
I definitely agree with them. Yeah,
I agree that I should be allowed to, but I don't know that anyone else should be allowed to necessarily.
Well, luckily you don't get called as much during movies now that we've switched to edge workers. So
that is true. That is true.
All right. If nobody else wants to share any, I can play the outro and then we can end the episode. Is that good with everybody?
I mean, I could come up with an unpopular opinion. Like, let me see.
I mean, it's up to you, Chris.
Let's see.
Adam, I feel like you have lots of unpopular opinions too.
Yeah. Okay. I mean, one of them is that I think Kubernetes is way overused in the tech industry. I think that there's a lot of people that don't need Kubernetes that are using it and could do something like a lot simpler to just like get their servers deployed. Like we're using Kubernetes, and I think that we shouldn't be using Kubernetes in retrospect. Like, so that might be an unpopular opinion. Although I've sort of seen some chatter online of some other people starting to realize that as well.
I feel like it's like a split. Either you're someone that's been burned by this, so it's a very popular opinion, or you're still in love with Kubernetes, so it's a very unpopular opinion.
It's kind of like using like third-party libraries or frameworks in like a language like Go. There's some people that are absolutely adamantly against it, and then there's other people who are like, it's worked pretty well for me, so I'm fine with it.
Yeah, I was at KubeCon last week in Amsterdam, and I would say there's a lot of energy in the enterprise for like large enterprise companies that have hundreds of services, microservices that are running on Kubernetes. And yeah, it makes a lot of sense for those. And there's a lot of tooling built around it. But if you're a smaller company and maybe a lot of your workloads are at the edge or in SDKs like us, and you only have a handful of services you need to run, it's probably overkill and is more likely to cause downtime than improve your team's productivity. And I think that's what we've experienced so far.
Yeah, everything is great until the first time you have to go diving into like the kube system namespace to figure out like which of the internal pods is having a problem or what's gone wrong with the cluster.
I mean, I could definitely agree with the sentiment that it's probably better to teach people that there are other approaches to deploying and like making sure that they're aware of that and they don't feel like Kubernetes is that's where we all end up being anyway. Because I've definitely seen enough small projects where they're just getting started where essentially they have Kubernetes running before they have 10 users or something, and you're like, I don't know that was required.
Yeah, like I think there's not too much knowledge about sort of like the simpler ways to get your code running on a server. You don't always need to build an entire like orchestration system to get something running.
Bring back Heroku.
I loved Heroku, man. Heroku was awesome. I used it at so many hackathons.
Heroku was awesome until like. I felt like it was awesome until you like had to actually scale up and your bills just skyrocketed.
Oh yeah, but it's like something to just get going, right? It's like I have some code and I just need it. Yeah. I just need it to be running. Like I just need some endpoint that people can hit. Like it was awesome for that, which is why I used it at hackathons. It's the best way to just get your code deployed.
I feel like when Heroku was popular, no one was saying that it was cool and good, and now that it's kind of it's on the brink, and everyone has all this nostalgia for it. Like, remember the good old Heroku days? Nobody backed it when it was new. It was
Thanks for making me feel old, Brad. Come on.
I have mixed feelings there because if it was like a hackathon project, I used it all the time. But as soon as it became like a paid something that needed to scale up a little bit, I immediately was like, I need to move my stuff over somewhere else that's cheaper. Or in the case of like a lot of startup incubators and things like that, you would end up getting credits for Heroku. And I don't remember what they were, but they were insanely high amounts of credits, like $100,000 in Heroku credits or something. So like in those cases, you just didn't care because you're like, it's going to be really hard to burn $100,000 in like the 1 year time limit you have for it. So you're just like, I just don't care right now. But as far as like an actual paid business model, it'd be hard for me to be like, yeah, I really missed paying $40 a month for some app that served 10 people.
Or $1,500 a month for a database that was
actually worked.
redundant. Yeah.
That's why I love usage-based billing for like all these edge runtimes and things like that. It's just like, just pay for what you actually use. That's the way to go, I think.
Yeah, wasn't our bill like $10 one time for like entire like months of traffic?
Oh, for certain things, yeah, for certain like services. Not obviously not our main.
Not for like the main platform, yeah. But I mean, it's like for like tens of millions of requests, it was like $10 or something like that.
Yeah, you can get a lot of free requests out of some of these services these days.
All right, Chris, did you have something you wanted to share?
Yes, I have a slightly, I guess it's like slightly spicy, but I think that all of this AI stuff that we're doing right now, all of this ChatGPT and Copilot and Midjourney and all of that is like last year's NFTs and like 3D printers from a while ago and from Segways from forever ago, where it's not like it's going to go away completely, but it's going to move into much more niche markets, and it's not going to do the things that everybody is screaming that it's going to do. Like 3D printers are a great example. 3D printers are wonderful. They're amazing. People use them all over the place. But like a decade ago, people are like, every single college kid's going to have one of these in their dorm room, and they're going to be 3D printing every single thing that they need. And it was just like, no. And like last year, we were all doing with NFTs, and it was like, NFTs are going to revolutionize how every single thing works. And it's like, no. So I think AI is in that same hype train, movement at the moment. And I mean, I personally be very happy when it kind of moves on and we can get to like the place where we're using the AI in very useful places. But yeah, I think that, everybody that's like, we're so much closer to artificial general intelligence and all this other stuff because we have these large language models. It's just like, no, it's gonna die down. I would say 6 months, but that feels a little aggressive.
Are you implying that VC Twitter doesn't know what they're talking about?
Yes. I said it was spicy.
It's
pretty spicy. I would agree with you that though at the higher level that like the term AI I think is a bit misleading. Like I don't think these LLMs are artificial fully intelligent yet, right? But they're extremely valuable. Like the difference between the AI hype cycle now and the NFT grift that happened a year ago is very different. Is that there's actual like real world like value that you can get out of like ChatGPT. I don't know, like us internally, I think Adam can talk probably for another hour about how we've been using ChatGPT internally to help us accelerate a lot of stuff. But like for us as a developer, like for me personally, like I've never been the best Bash programmer or SQL programmer, but now I can like type into ChatGPT and be like, hey, write me a SQL query that does this. Here's the table schema, figure it out. And it just goes and does it. And it's like accurate most of the time. And then if it gets it wrong, you just paste the error code into ChatGPT and then it like rewrites the SQL query based off the error code and like fixes itself. It's like, that is just like truly, I found it truly really accelerated the pace of my development over the last couple of months.
Yeah. I feel like, because I think the NFT point's a good one too, because it's like the idea of having this kind of distributed ledger that you can use to kind of mark the progress of items over time and kind of track the chain of custody of things is like super interesting, but also like super niche. And, for a lot of us in software engineering, like not a huge thing we care about right now. But I think there are markets like, white or like a wine or art collection or things like that where it'd be super interesting. I think ChatGPT, one of the applicable places is, things like software engineering where when it's wrong, we are well aware that it's wrong. So I think there's a lot of things right now where people are even like the words they're using kind of irk me a bit, which is kind of where this whole like unpopular opinion comes from, when people are like, oh, the large language models, they're hallucinating. And I'm like, it's not hallucinating. It's just producing statistically accurate results that are wrong. So it's like the prediction engine got it wrong, just like when autocorrect gets it wrong. It's like it got it wrong. It didn't do anything different than what it's doing before, and people are just interpreting it differently. So I think it's like in places where we know what the correct answer is, or know at least what the correct answer should look like, and can tell like, okay, that's not right, I think it's fine to use. But in areas where we don't know that, it can be very dangerous.
I think it's similar to self-driving. Like all the hype around self-driving cars, we haven't gotten that close yet to like a full self-driving car that can, like I live in Toronto, that can drive in the winter when there's snowbanks and stuff like that. It's like we're nowhere near that. But we have gotten to the point where like every car you buy now has like really good, even like a cheap Toyota has like really good like lane keep, lane centering that works like amazingly on the highways when it's like nice out, right? And so like that's kind of like how I think about it, is that like we may not get to like the pure like self-driving cars for like another, I don't know, 20, 50 years, but there are like incremental improvements that we're seeing like now and today. And I think with AI, we're seeing similar improvements there.
But see, you just agreed with me.
I did, yeah. I kind of did. Yeah.
I mean, I think the problem is it depends on how you view it. Like if you're expecting AI to become like perfectly 100% accurate all the time and to like do all this stuff perfectly, I think anybody who's thinking that is going to be disappointed, because I think that's going to be really, really hard to do. Same with like self-driving cars. But I think there is a use case for something that gets like 90% of it right. And like there's certain cases where it's very good at it. Like self-driving cars are an example of, if I had a car that literally just could drive the highway, like nothing fancy in the city, nothing else, just long highway stretches, that would be like a miles and miles of improvement compared to what I'm currently at. So like
we're pretty close to that.
Yeah. So like it doesn't have to be perfect. It can skip all these other edge cases as long as it does like a couple core ones exceptionally well. And I think we can work towards those ones. But I think the problem is people get that idea in their head of like, we're building towards the perfect drive everywhere, like self-driving technology, or if it's AI, they want AI that's 100% accurate, doesn't do anything wrong ever. And I think that's, people who are expecting that are going to be disappointed. But I will say that I feel like the one thing I've liked about the AI, like the ChatGPT and everything, is I feel like it's helped a lot of non-technical people see how much more they could use computers to like solve menial tasks in their lives. That like developers, we all knew this could like, we're like, oh yeah, that's easy to do. And there's even things that I see people doing with ChatGPT that I'm like, you could have done that before ChatGPT pretty easily, but they just didn't know how to do it. So like now they're like able to leverage that, which is nice. I mean, I'm even thinking like Clippy inside of Microsoft Docs. If that was released now, I feel like it would never go away. Versus like when it did release.
Well, basically is being released now. Like Microsoft is essentially trying to like reintegrate something like Clippy into the Office suite, right? Like they're adding like a chat interface.
I mean, I'd love it if it was actually Clippy there.
I'm sure somebody will make like an add-on that'll just change the icon. But yeah, I mean, I think it's kind of like the last 10% problem that people always talk about. And like the difference between self-driving cars and AI is that like with self-driving cars, like you had the example earlier of like the perfect lane keeping on the highway. Like that's really useful and like it's useful today. But the problem is that like for driving fully on like city streets, like you're still going to need to pay attention. And so like anything additional past like the perfect lane following on the highway isn't like that useful until it's perfect. Because even if it can mostly drive in the city, that doesn't really like help anybody, because you still need to have your hands on the wheel. You still need to be paying attention. So it doesn't like reduce or help the driver in any way, right? It's just kind of like a neat toy. Whereas with AI, like even with 90% of the way there, you can do a lot of things already with it that are really, really useful. And I think at this point, it's more just like a UX problem. Like I love kind of just like scrolling through Twitter and seeing all of the really like interesting and novel like ideas that people come up with on like how to use this stuff. And like most people, like it wouldn't even cross their mind to try that. But that's not necessarily a problem, because, in like 5 years, like most of our software will probably use something under the hood to like add a lot of that functionality that people are like sort of using ChatGPT for now. It'll just have a way better interface. You won't have to like explain to it sort of like what it's supposed to do. It'll just kind of like be able to do it. So I think that part of it is really exciting. Just kind of seeing like how it can be kind of like weaved into like existing software in like a really seamless way.
Yeah. I've had this argument for a while that like these large language models are sort of like fancy compilers, and that if you don't know what they're doing, they look a lot like magic. And they are like compilers also are, to some degree, they are magic. Like the things you put in and then the stuff you get out, you're like, I don't know how that happened. But when you think about it in the simple, like the pieces that are used to make it, it's like, oh, well, this actually, like, I can comprehend this. This isn't like some sort of thing that's beyond comprehension. But when you start to scale it up, it's like a confusing, it can get very confusing because humans are bad at big numbers. It's like that classical thing of the difference between $1 billion and $1 million is $1 billion. And when you say that, people are like, that doesn't sound right. But if you said the difference between $1,000 and $1 is $1,000, people would be like, well, yeah, of course. So I think it's like when you get to those large numbers of things, whether it's like a large number of compilation instructions in a compiler or a large number of weights in a large language model, it starts to get like interesting in what it can do and how you can apply it. But once again, I think it's like, that's not necessarily who I was like, I feel like those are still like movements into the niche kind of areas of like, oh, these are these cool, interesting things we can do with this technology. Maybe even at a spicier take would be for both self-driving and AGI, we will never actually achieve those things, but it's still good to continue going on because all of the byproducts are very useful things for human life and augmenting human life.
I think a lot of people say we can't achieve self-driving without AGI. So if we can't achieve AGI, we can't achieve self-driving either.
I mean, there's a whole bunch of reasons why we might never achieve self-drive. Like, I don't know, maybe we won't have cars in the future. Maybe we'll get really, really good at public transportation and just not have a need to drive.
Oh, don't get me started about public transportation. I can go on another hour rant about that.
Toronto just started building their third subway in downtown after like 50 years.
I live in like rural America, so like the idea of public transportation is non-existent here. I think there's like literally the town I live in has, I think, 2 taxi cars, and they're not always running. You have to like call and schedule stuff with them. It's not like you wave down a taxi. Lyft and Uber don't exist where I am.
Oof. You know, there's like glimpses of possibility. Like I watched this really cool video about Switzerland's train system where it's just like, oh yeah, there's this like random ski lift and coffee shop that I think there's a hiking trail. It's like, oh, it gets train service every 30 minutes all day long. And like, oh, it's possible to do rural trains that function? Oh, okay. But yeah, for Americans, I think especially, it's very hard for people that live in rural or suburban places to imagine high quality public transit.
I think sometimes it's almost like they need to experience the benefits to really see them. Like there was, I forget which cities, I think it was like Tennessee and some other city. They were talking about putting a train that would like get you from one to the other in a couple hours. And I'd heard people on a podcast talking about it, and they were like, you know, what's the point in that? And I'm like, yeah, it doesn't seem very useful until all of a sudden you can just zip over to that other city and you find yourself doing it way more often than you would have otherwise because it's so easily available. Whereas like when it's, you know, you have to hop up in a car and drive 8 hours, or you have to fly, and that's going to take, you know, everything that's involved with flying. You're not going to do those things all the time. But a train is super easy most of the time.
Yeah, I remember it like blew my mind when I was visiting London and I realized that I could take a train to Paris in like 2 hours. And I was like, wait, I like this trip I was going to visit London, but I can also just go to Paris and just like hop on a train to get there. Like that's crazy.
All right. I think that's it. I'm going to play us out and then I will stop the recording. Thank you guys for joining. Jonathan, Adam, Brad, thank you guys for joining. And Chris, thank you for helping me host.
Of course.
Thanks for having us.
Thanks for having us.
One cool thing about our new changelog newsletter is that we don't proxy links like almost everyone else does. That's awesome because A, there's no tracking, and B, you can hover on a link to see where you're headed before clicking. I do that all the time. If you appreciate direct links as much as I do, pop in your email address at changelog.com/news because the software world moves fast and we'll help you keep up the easy way. Special thanks once again to our partners Fastly and Fly for helping us bring you awesome pods each and every week. And of course, thank you Breakmaster Cylinder. These beats are banging. Next time on Go Time, Chris, Angelica, and Ian are joined by Andy Walker to spitball a new style of conference they're calling Hallway Conf. Stay tuned right here. We'll have it ready for you next week.